Good morning, everyone. We'll get started right away. We have a morning of berry topics for you today. I'm Shauna McKinnon. I'm the coordinator for the BC Agricultural Climate Adaptation Research Network. And the ACRAN network is helping host today's workshop along with Dr. Julie Carrillo from the University of British Columbia. We have a great lineup of topics and speakers for you this morning.
Welcome, everyone. Thank you for joining us. My name is Julie Carrillo. I'm a faculty member in Land and Food Systems at the University of British Columbia with the Center for Sustainable Food Systems. Just a bit of background on this workshop. We wanted to organize something to get an early season look at how extreme weather events from the last year in BC, including flooding, extreme heat, and now this very wet spring, and how changing climate in general may impact berry growers. This workshop was organized as part of a Genome BC sector innovation project, and we thank them for their support. I'll talk more about some of that project later on in the workshop. So I'd like to introduce our first speaker, Dr. Eric Gerbrandt. Today's workshop is starting with field-informed management recommendations for berries that were impacted by the extreme flooding last November. Dr. Gerbrandt is the research director for the BC Blueberry Council, the Raspberry Industry Development Council, and the BC Strawberry Growers Association. And he's been working with his US counterparts to evaluate the impacts of floodwaters on berry crops and soils and develop guidance for management. So welcome, Eric. Thank you for joining us today, and I will pass it over to you to share your screen.
Great. Thank you, Shauna and Julie, for your introduction and for getting the event started. I see we're up to 22 attendees, and I see one person introducing themselves. So I do love to see who's on a call, and I don't know all of you. So please introduce yourself if you just joined after that first announcement, and you can do so through the chat. All right, so I was introduced, so I'm the research director with the three berry groups representing blueberry growers, raspberry growers, and strawberry growers here in British Columbia. And I'm a horticultural scientist working in variety evaluations and developing better ways of producing berry crops. So I'm gonna start with figuring out how to advance slides for my screen here. So just anybody that's not familiar with the three berry groups that I work for, I mean, I see Miranda Elsby's on here with cranberries, but I work for the other three berries, the BC Blueberry Council, Raspberry Industry Development Council, and BC Strawberry Growers Association. And these are the organizations that represent those three commodity producers in BC. As a group, we work on a lot of collaborative work. We have a joint breeding program to develop new cultivars of blueberry, raspberry, strawberry, based largely off of Agriculture Canada land, but also off of private lands. We work on projects such as work that's been funded in Julie's lab on managing key pests like spotted wing Drosophila, but we also have similar disease issues. Some diseases are similar, and so there's some overlap in the type of research that's done across berry crops. And then we're also working on developing capacity in the area of climate change adaptation and climate change mitigation research as it pertains to the context of berry production in BC. All right, so we've been through a few things this last year. I mean, winter damage happens every once in a while in berry crops to one degree or another. Last summer, we had the big old heat dome that coincided with the beginning of the raspberry season, as well as the blueberries were just coming on at the time. Strawberries were coming ripe at the time of the heat dome. Had a lot of heat and UV stress that caused cellular damage, but there was variation between varieties, microclimates, and field characteristics. I'm not going to go any further into this because we have another speaker that's going to cover heat damage, but just to give a context that we had, to give a context on the flooding situation that came a few months later, we had just gone through a very stressful summer where you can see here in the top left-hand corner is some Duke just coming ripe, and they got quite a bit of damage on some of the riper fruit. And then just below that is a picture of some Calypso, which is a mid-late season variety that was not yet turning blue, but also suffered from severe UV and heat stress in the heat dome. Likewise, in raspberries, there's a big difference between varieties in terms of how much damage they sustained. Varieties that were relatively early and that got hit just as they were coming ripe, sustained more damage on average than varieties that were later in the season. But I'll leave that topic of the heat dome for other speakers to address, and go to our topic of the day, which is to talk about the unprecedented flooding that we saw here in November and December of 2021. As we've kind of tried to break this down into varying degrees of severity, we categorized low to moderate severity of flooding versus high severity flooding and extreme severity flooding. And I'll give a bit more definition of that in a minute here. But in general, we struggled with anoxic stress on plants and on soils. And I'm going to go over some of what we've been able to put together as a group of researchers across the Pacific Northwest to provide growers and other scientists with an understanding of what's going on and what to expect. So currently we're at the last day of May. Plants are growing in the field, and there's a lot of recovery going on, whether or not growers replanted their field or simply did renovation, pruning, or repaired their field to the extent that was required. So just an overview of some of what we saw when the floodwaters receded and we were able to not go in canoes, but actually go out to the fields to take a look at damage. You can see on the left-hand side there's some black shoot tissue on the previous season's growth. There's below that, the bark's been shaved away from a young first-year shoot, and you can see that those tissues are pretty much dead. There's no green tissue in there. On the right-hand side, we've got a field that wasn't underwater for very long, but had quite a bit of water movement at the same time as flooding that caused for the roots to be exposed at the top of the plant. That can really result in the plant drying out as soon as it gets hot, because the soilless media that blueberry plants are propagated in is highly porous, and it basically just wicks the water out of the top if it's exposed once the sun comes out. And then the picture in the bottom right hand corner there is an example of the death of macrobiota in the soil, so a bunch of dead earthworms that passed away in the flooding. So during this event and following it, a group of experts across the region in Washington, Oregon, BC, we got together to put together our best guess at what growers would expect once the waters receded. That's on the left-hand side, the first document we published or disseminated as a white paper. And then following the flooding and after the waters receded, we tried to provide some more in-depth guidance on what to expect, and broke this severity of flooding into those different categories I just mentioned, and provide some guidance on how to go about managing fields that have been affected to varying degrees. I'm just going to take a pause here and take a look at who's on the screen here. There's some people with only one name, and I didn't know who you are. It's great. It's good to see so many people from different walks of life and different parts of the sector here. Okay, so basics of flood tolerance in berry crops. So most berry crops are actually quite tolerant to flooding for short periods of time. Flooding happens in a lot of different production regions on an annual basis in many cases. And the flooding that we sustained was actually occurred at basically at the peak of endodormancy. So for example, and I'll focus on blueberry for most of this talk. In blueberry and most woody perennials, peak endodormancy, or the degree to which buds are resilient to breaking and growing again, that actually peaks around the same time as about 95-100% leaf drop. And we were approaching that in many of the fields. Though there were some of the varieties that dropped their leaves later that may have not quite reached that endodormancy peak. And that's distinct from a cold hardiness peak, and growers were concerned, oh, my plants aren't fully hardy. Well, they were not necessarily fully hardy to extreme cold temperatures during the winter, but that cold hardiness is not exactly the same as the endodormancy processes that dictate the pace of metabolic activity. They're parallel processes in terms of how they develop, but they don't have the same timing. So The one saving grace that we had and when the flooding happened was that most of the blueberry fields were approaching peak endodormancy, which would confer the maximum amount of resistance to damage resulting from anoxic conditions during flooding. Nonetheless, even if you are at peak dormancy, plants don't just go into cryostasis. This is not science fiction here. They do require oxygen in order to perform regular metabolic processes, respiration in particular. And so under low oxygen, the demand is not zero for oxygen at that state. And eventually under severe flooding, and so long duration, high depth of water, eventually oxygen supply in the plant cell tissues will be exhausted, and then abiotic cell death will result. And that damage is cumulative over time, might start at 1-2%, and then as days progress, we'll add percentages and get into the double-digit percentage of plant tissues being severely impacted. And this happens in both the roots and the shoots. So even if the shoots are at maximum dormancy, they still have tissues that require oxygen in order to maintain viability during the dormant season. And beyond just the plant itself, there's also long-term, short and medium-term impacts on soil structure. And in particular, in the Sumas Flats area where the flooding was most prolonged, we had a deposition of a 1/2 inch to 1 inch of really fine textured soil particles like clay and silt that created a wet blanket on top of the rows of berries. And that, in my opinion, contributed to prolonged hypoxic conditions. So prolonged low oxygen conditions that continued long after the anoxic conditions or no oxygen conditions of the flooding event itself. So even after all the water had drained, having that thick layer of fine textured sediment on top of the soil would have contributed to sustained low oxygen conditions and potentially continued accumulation of damage. So let's break it down. These are really subjective or arbitrary categories of breaking down the severity of flooding, just based on how the different scenarios that rolled out in different parts of the Fraser Valley during the flooding event. So low and moderate severity would be like less than 10 days and usually less than 3 feet worth of water. That being said, under low and moderate severity, there was also often quite a bit of water flow. So water flowing through the field that caused erosion. So the direct effects of flooding may have been not as important as the indirect effects of soil erosion. High severity is anything we call between 10 and 14 days. That could be more or less than 3 feet, just depending on where the flooding occurred and how quickly it drained from that area. And then the extreme severity, which we deemed relatively unprecedented for this region at least, is when they were under for 14 days and up to 10 feet. And some fields, I think the longest was 23 to 24 days underwater for the root zone in particular. And so we wanted to break it down into these levels of severity to provide some nuance to what we would expect in terms of plant responses, and then compounding that, not just the depth and the duration of the flooding, there's other aspects that would impact the degree to which a plant would be damaged by flooding. The soil texture, how heavy the soil is, the amount of water movement through the field, as I mentioned, for some of those low to moderate severity flooding situations. The age of the planting, typically we would expect for younger plants to be more susceptible to whole plant damage based on the, I guess you got less wiggle room when you have a small amount of biomass. And so typically we looked at age of planting as being negatively correlated with plant outcomes. And then or young aged plantings being more likely to be damaged severely. And then there's a range of strength of a planting before an event like this. Some plantings are just not as vigorous. They've got pre-existing issues with water, a high water table, or some other factor that's causing root or shoot issues. We have weevil issues in this area that can really sap the strength of a planting. And so we expected that plants that were already in a weak state going into the flooding would struggle more with that additional challenge. So we'll go over some aspects of the low to moderate severity flooding to begin with, and then move on to the more severe case. So I mentioned this a couple times now already, that moving water really caused a lot of trouble in these circumstances, exposing the tops of the plants. And sometimes this could be repaired merely by going through and by hand putting dirt on top of the roots to prevent them from drying out, or remounding with a tractor, though those sorts of operations are difficult to do in a saturated soil without causing additional damage to the soil structure. Driving tractors over heavily saturated soils was avoided by growers because we didn't want to compound the issues with compaction. In other cases, plantings where the high raised beds had been eroded to such a point that they weren't what they were intended to be when the grower planted them, formed them and then planted into them rather. Some of those fields actually needed to be replanted despite the short duration of flooding and perhaps only a couple of feet of water. Only a couple of feet of water. That kind of makes it sound like it's not a big deal, but it is. And so in some cases, growers were better off starting from scratch, because if you want to get a good established highbush blueberry field, having raised beds that are not adequate for the soil that you're working with, or the field architecture, and having roots exposed is really not a good way to get a planting started. And so starting from scratch was advisable in many situations. I'm going to go over a few different topics here, some different concerns that growers had, and some of the advice that we developed as a team of researchers and extension folks. The first one was the erosion, as I just mentioned, not only the roots drying out, but also the layer of sawdust mulch that is over many of the beds of many fields in the Fraser Valley, and recently applied fertilizers. We do a lot of potassium and phosphorus applications in the fall, and a lot of that was lost. So, it washed away, and who knows where it went. So some of the recommendations that were made were replant or replace soil that was lost. Do some reevaluation of soil nutrient analysis. We don't expect the major parameters of the soil to change, the pH, organic matter. Those things are really hard to move, and it's not like the water actually percolated all the way through the soil volume and washed things away. Most of the water that was in these flooded regions was actually pumped out of the area through drainage canals. And so, we didn't expect a huge swing in the nutrient content of the soils, but we did recommend revisiting soil tests, and then taking a look back at the original fertility plan and tweaking it with the concept of finding a way to get plants to recover as the primary objective. Another concern about soil structure was the loss of, was the loss of soil structure. So we get physical compaction from the weight of the water on top of the fields. And then there's the deposition of that fine layer of silt and clay, decrease in soil aggregates, so the clumps of soil that provide the interface between roots and air and soil water, little soil particles clogging up the air spaces between aggregates, and all of that resulting in a decreased rate of water infiltration through the soil. We hoped, in January and February, some of the cold weather that we had would help to improve some of that soil aggregate and some of that soil structure through the freeze and thaw cycles. And then we also expected that having high raised beds and alleyways in between would facilitate some of the drainage of water from where the roots are actually growing into areas where blueberry roots are not actively growing between the rows. So some recommendations there, and these are kind of difficult to see how, to know whether or not they would have much of a short-term impact. They're more medium and long-term things, is to do cover cropping between the rows, which can help to restore some of the soil structure in the alleyway, make applications of organic amendments to provide humic substances that can help form soil colloids, and then subsoiling again when the field conditions are conducive to actually driving a tractor in there to provide a place for the water to drain in subsequent rain events. Some other concerns we had on the soil was that pre-emergent herbicides that had been applied in the fall were likely all gone. And then weed seeds would be moved from field to field and within fields. And so we recommended revisiting the approach to pre-emergent herbicides in the spring in order to, in anticipation that there would be potentially more weed problems. And then as we're experiencing now, we're just encouraging growers to remain vigilant in the field to look for new weed issues as they arise. They might get a new species of weed that they've never had on their farm, and so they'll need to keep an eye on it to know how to manage it. And then we had a loss of soil microbial life, macro and micro life. I showed the picture of the drowned worms. Some of the smaller forms of life like bacteria and fungi, some of them would have been dormant at that time and could probably now be waking back up and reestablishing. The rate at which different aspects of the soil microbial community reestablish themselves is really going to depend on the soil type and the type of organism in question. And I'm not going to pretend to be an expert on that. Julie might have a comment on how that might look. And a recommendation, I don't have a real strong one here. It's possible that under some conditions, the application of humic acids might be beneficial to provide some substrate for soil microbes to feed upon in order to restore their populations. But that's probably not a one-size-fits-all recommendation, in that humic acids might not do much of anything on a high organic matter soil that already have a lot of humus, a large humus component that is in various stages of decomposition already. And then getting to the roots, so that's the soil. We'll talk about the roots and then the shoots. So for roots, anoxia and hypoxia, so that no oxygen, low oxygen conditions result in progressive cell death. The size and the health of the root system going into the flooding event, as well as the duration and the depth of the water on top of those roots, would dictate the relative amount of damage sustained by a particular planting. And as I stated earlier, we'd expect that younger plants would suffer more. They just don't have as much of a biomass to be resilient to loss of functional tissues. But root regrowth is possible even in blueberry that have a particularly unique root system in terms of their adaptation. They're bog plants without fine root hairs and with a fibrous mat on the top of the surface of the soil. So even though they do have a bit of an interesting root system, we do expect that a certain amount of damage can be recovered from as the plant attempts to reestablish itself. And so for dealing with the damage to the root system, we recommended to remove most of the above ground plant matter in severely flooded situations in order to take the demand for water and nutrients off the roots so that they're not stressed while they're reestablishing. And then all of that with the intention of supporting the reestablishment of a new above ground plant architecture. Speaking about those above ground plant structures, I've got a picture there two pictures on the right there, one of some dead fruiting buds, and some, I showed this picture earlier as well, is dead vascular tissue scraped away beneath the bark. So just as with the root cells, above ground parts of a plant, they can suffer from plant cell death, and this leads to necrosis. The extent of damage would also depend on the depth and the duration. So in some fields that had 10-foot tall bushes, the most susceptible tissues are the younger new growth. But if they're up top and they were underwater for a week less time than plant tissues that were 4 or 5 feet off the ground, then maybe they got away without being damaged quite as much as, say, a first-year shoot that's growing from the base of the plant that was underwater up to 8 or 10 feet and for up to 3 weeks. Most of the fruiting and vegetative buds that were underwater for 2 to 3 weeks, those buds mostly died. And that's just because they're the most susceptible tissues on the plant. But then we also were seeing this death of the outer bark and the cambium and the phloem. And then we saw progressively less damage as you go down the plant towards older tissues that have got thicker bark and have dormant buds. And as I'll show you in just a few minutes, a lot of those dormant buds under the older bark, they did actually survive, and they are now facilitating the reestablishment of these plants. So the recommendation for the above ground plants is similar to for the below ground portion of things. Is we need to remove most of that top growth to give that root system a chance to return to full strength. And the degree to which that above ground pruning needs to be done really depends on the field by field situation. So during, I think this was in January, we went out and gathered a bunch of canes from different areas within the plants and took cross sections of them. So on the left-hand side, you can see the relatively low growing, maybe 5-6 year old wood in a Duke field. In the middle is wood from the middle of the canopy, about 4 feet up off the ground, and that might be 3-4 year old wood. And then the picture on the right is stems of the previous year's growth. On the left-hand side, we're not actually seeing much damage. Those are healthy tissues. The middle picture, there's some damage to those canes, but then on the right-hand side, the younger tissue, most of that was in the early stages of necrosis. This having been taken from the field pretty soon after the flooding event. Likewise, here's a younger planting from just across the street from the first one. Even the older, even the older tissue from lower down on these plants sustained considerably more damage, and that's in line with what I was saying earlier about younger plants being relatively more susceptible to damage than older, well-established and large plants. Another picture of some assessments. On the top, we've got a flooded Duke field, and on the bottom, we've got an unflooded Duke field, and I peeled away the bark on various ages of wood to compare the viability of those tissues. And you can see on the left-hand side, the older wood, it's all pretty much the same. In the middle, the more moderately aged wood on the plant was virtually the same between flooded and unflooded, but it was really that younger wood where you can see on the top here, that stuff's all dead as compared to nice green vascular tissue down on the bottom picture there in an unflooded field. Okay, so some concerns about diseases in flooding fields, and we had some pathologists on the team provide their opinions on this. Phytophthora cinnamomi is the pathogen that impacts blueberries, and the assumption is that in fields where that pathogen is not present, that the flooding would not really exacerbate that issue to any large degree. However, flooding can promote the spread of Phytophthora root rot because they have a mobile zoospore stage, and Phytophthora cinnamomi is active during various times of the year, more during warm periods than cool periods compared with Phytophthora rubi, which impacts raspberry. But nonetheless, there is the risk of spread of the pathogen within fields that already have that disease in the soil. So in situations where Phytophthora is at play, some recommendations include the use of metalaxyl, oxythiopiperlin, and phosphites. Though these products won't do anything if it's merely abiotic cell death. They're really going to be of import for biological issues pertaining to the oomycetes that cause root rot. Nematode populations, we had a nematologist down in Oregon weigh in on this side, and she indicated that there was some positive and negative impacts. Mentioned that in the Netherlands, they actually use flooding to try and control nematodes. But then on the negative side, there is the potential for the movement of nematodes in the landscape, in the soil. They are soil living organisms that just so happen to be they are water living organisms that just so happen to be in the soil. The impact of nematodes and the relative degree to which they are involved in poor root health in blueberry fields in the Fraser Valley is something that's currently understudied. We've got some plans to develop research projects to look more closely at how big a player nematodes are in blueberry fields. And so combined with our lack of knowledge in that area and with the fact that there's potential positive or negative impacts of flooding on nematodes, we didn't really come up with any firm management recommendation to deal with nematodes aside from what is already done. Other diseases to be concerned with: bacterial blight and fungal canker. I showed you pictures of blackened tissue, and that was right away. That was a day after the flooding had receded. I was able to get into the fields, to document things. That if you showed the pathologist the two pictures on the right here, they would say, oh, looks like you've got some Pseudomonas. But it's not Pseudomonas, it's just straight up abiotic cell death. However, once you've got damage to plant tissues, those become entry sites for pathogens to begin to establish, particularly Pseudomonas syringae loves to have a nice wound in plant tissues in order to get in there. And so our concern is that, especially with the young planting where Pseudomonas can get right down into the crown and kill the plant, the priority is to remove all that necrotic tissue via pruning, and then use the bactericidal and fungicidal products that are available to protect the above ground structures that remain. In the case of bactericides to control Pseudomonas blight, we're pretty heavily reliant on copper. It's really the only, there's a couple of biologicals, but it's the most widely used. There's problems there in that there's a lot of copper resistance in the Pseudomonas populations in the Pacific Northwest. And so growers can only really do the best that they can with the tools that are available to them. And so we also recommend maintaining vigilance throughout this season, keeping a close eye on what diseases develop and then getting on top of them as soon as they arise. A pollination expert from Oregon weighed in on some potential impacts on pollinators. So managed honeybees, if they went underwater, I'm pretty sure they would have a 0% chance of survival. However, we are fortunate that in most of the flooded areas here in BC, most honeybee colonies are not overwintered there. A lot of them are taken to the prairie provinces and brought back to the blueberry industry at this time of year. And so I hope we didn't lose too many honeybee hives, though I'm sure there were some out in the flooded fields here and there. Native bees, there's a lot of ground nesting species out there, and most of them were expected to suffer losses. I think there's one species of bee that forms a little carapace around itself that could protect itself, but most species would probably have drowned. And then we would just need to wait for those populations to rebound as they get repopulated from adjacent areas. And the degree to which a field will reestablish with native bees and the speed at which that will happen would vary based on the species and how its behavior in terms of how far it moves in recolonizing areas, as well as its reproductive rate and how far a particular field is from a source of new bee populations. And then beneficial insects, and I won't go any further into this. I think a lot of them probably some of them were killed at least by the flooding. However, repopulation rates are going to vary, and we'd expect that in the next year or two, we would have a return to normal in terms of the beneficial insects that are present in fields, in the same way that we'll expect that all of the pests will return into their regular abundances in the months and years to come. So as this was all unfolding, there was a lot of unknowns. Growers concerned that their plants were completely dead, or that they would fail to recover. And so in February, we went out and dug up a bunch of plants and took them into a greenhouse with artificial heating and lighting. We did this after the plants would have received the majority of their chilling, probably more chilling than they require, being here in such a high chill region. And then we assessed their regrowth after stumping. We stumped some plants and didn't stump other plants in order to forecast what we were likely to expect, just give ourselves a little bit of advanced knowledge of what was going to happen to the plants in these severely flooded fields. And so you can see after about 3 weeks after bringing the plants indoors, they're beginning to regrow. On the left-hand side there is a plant that wasn't pruned to the ground or down to about 18 inches. And in the middle is a plant that was stumped down to about 18 inches. And then on the right-hand side, it's kind of glowing because there's an LED light above it. Those are shoots coming up off of the base of the plant, which was a good sign. So we were hoping for regrowth from some of that older wood, because if you left the top canopy, you would get some sporadic growth of buds that were able to survive the flooding, but then they'd be off in the middle of a canopy full of dead plant material. And so our idea was to take the growth down to about 18 inches or 2 feet, depending on the height of the wires in the field, and allow them to grow from points where they would establish a canopy that would be useful. Even though some of the buds that were higher up in the canopy started to break earlier under these artificial conditions, we were primarily concerned with getting wood that would establish a canopy that would be useful in the years to come. And so that's why we would stump them down, and even though those buds that are lower down, they'd be dormant buds, even though they would take longer to break, they would hopefully produce a more useful set of vegetative shoots. So some of the management options that are available to growers really varied based on all those factors we've discussed so far. So the age of the planting, the variety, its relative vigor or weakness, the severity of the flooding that occurred in that particular field, both in terms of the depth and duration, the speed at which the water was flowing, which impacted the degree of erosion of soil from around the plant roots. And then also considerations of whether the farmer wants to go with a new variety, if they have to replant, if there's considerations of the long-term economic prospect of that farm. Are they going to continue on with a variety that they might be able to get back into productivity, but is no longer a suitable variety for the market? Or is this an opportunity to restart with a cultivar that's more advanced and more acceptable in the marketplace? An example of that would be if an Elliott field is not, it might not recover fully. Maybe it's a good idea to take that out and replace it with something like Calypso that might have a better long-term opportunity for the farm. Okay, and so the management options ranged from just repairing eroded fields and reapplying sawdust. In some cases, growers are able to maintain some of the crop by just doing a hard prune and not doing a full renovation prune. In other cases, I use the word renovation, stumping interchangeably here. That's taking the plant right down to about 18 to 24 inches and then thinning out the canes to 6 to 10, depending on the size of the plant, in order to give it give the plant a good architecture to start with reestablishing of that above ground canopy. And then in other cases, field replacement was really the best option based on how much damage was sustained and the pre-existing condition of the field going into the flooding event. So here's some pictures, and you can see in the top left-hand corner in the background, there's some plants that have not yet been pruned. You can see all the dead growth up to about 5 or 6 feet, then a bit of red tissue at the top, which wasn't under water for quite as long. There wouldn't be much point in trying to reestablish a field from 5 feet up above the canopy, above the ground. It's better to take it back down to about the height of the wires and prune it down to 6 to 8 canes, as I just mentioned, as you can see on the right-hand side here. This is a picture from about a month and a half ago here. We can see the buds beginning to break on these newly stumped plants. And then in the bottom right-hand side here is a picture of a unpruned field, which demonstrates the negative impact of leaving a bit of living tissue on top of a whole bunch of dead tissue in the middle of the canopy, where that's basically useless growth. But this field in particular is likely slated for removal. So that's why it hasn't yet been pruned. And then this is a picture from just yesterday out here in the South Sumas, a field that was underwater for 3 weeks, about 8 feet of water in this field. And you can see excellent regrowth on most of the plants. We've got up to 10 inches of shoot growth. And now the next decision that needs to be made, and some recommendations should be developed here, is how to go about managing this canopy this year, next year, and the next year, before getting to the point where the plant can return to some semblance of its former productivity. We've talked about potentially using burning with Ignite on the sides, or some other product to focus the plant's growth on the canes that are coming up off the top of this plant. But in other situations that may not be advisable, just depending on how many shoots the plants are producing after having been renovated. So just a summary and some current conclusions, because really we're just learning as we go here. We don't have any I guess consensus on much of anything at this point, other than what we're kind of learning as we go here. So this was definitely some unprecedented flooding in some areas here, particularly in South Sumas area, in the Sumas Flats region. The severity of the damage really did range based on the pre-existing field conditions and the amount of flooding that happened, the depth and duration, and the amount of movement of water. And it's a combination of those two things that will dictate what management recommendations are best for each particular field. Some blueberry fields are being removed and replanted, others are being renovated, and others are just being repaired. And growers are doing their best to bring their livelihoods back into productivity. At this point, based on that final picture that I showed you, I'm beginning to feel cautiously optimistic for recovery. Plantings that are replanted, I'm hoping for a great restart for those plants. For the plantings that have been renovated, we hope that they will eventually return to full productivity. But there are questions that remain, and that'll ladder us into our Q&A period for the next 15 minutes if there are questions. First of all, how long is it going to take for the root systems to recover? Secondly, as we're renovating these fields that we want to bring back into productivity, how do we go about managing all those new shoots in such a way as to facilitate a return to productivity? And then the big question is whether or not any one field will actually return to its full level of productivity that it had back in 2021 or 2020. And I'll leave it right there. We've got my email address up here and my phone number, so feel free to reach out in either form, and I'll hand it back to Shauna, or maybe it's to Jennifer.
I'll take it. Great. Thank you so much, Eric. That was a really interesting presentation, and I'm sure it's very appreciated how quickly you turn to researching what the impacts are of this flooding. I was struck by your range of severity of flooding, and even those that, in this case, they were lower moderate severity, still very extreme compared to what's been experienced historically. So I'm sure that people have questions out there. I see people putting in some comments, and there's been lots of introductions, and we have a really wide range of expertise and people coming from different backgrounds joining us today. So please type in your questions for Eric, and you could have questions about some of the content that he covered today, but also I think suggestions or questions around some of the research that needs to continue now, as Eric already brought up some of these topics of the continuing research that's needed. If there's other things that came up for you thinking about these flood impacts in the blueberry fields, I think it would be great to raise some of those questions or add those in the comments as well. So don't be shy, especially because I know a lot of people will be watching this on the recorded version. So this is a chance for you to raise the questions that they won't have a chance to raise, and to tap into Eric's expertise and this work that they've been doing.
I should make one more comment. I'm just the messenger here. I mean, we had a really great group of people from across the Pacific Northwest. I wanted to acknowledge Lisa DeVetter with Washington State University. She was unable to join us. We were actually going to share this presentation, but she had some other commitments, but she has demonstrated really great leadership in kind of rallying us together and having a lot of different experts weigh in on things to the benefit of growers. So thanks to Lisa. Ooh, we got one question.
Yes, so thank you, Tracy, for starting things off here. I know you're going to warm it up for others. Yeah, so Eric, how bad was the damage comparably in the Matsqui Prairie?
Right, so Matsqui and Glen Valley, they were not as long underwater as in South Sumas, or sorry, in the Sumas Flats, but there was a lot more flowing water in a lot of situations. So and honestly, I didn't spend as much time in those areas, but from what time I did spend there, I saw a lot more of that low to moderate severity, but not necessarily less damage, because even if the water wasn't there for as long, so some fields were underwater for quite a while in Matsqui, even if a lot of the fields were not underwater for as long as in Sumas, there was a lot of flowing water. And so I think it caused quite a bit more erosion, particularly those newly planted fields. A lot of them had to be redone because there's no point in forming a nice big raised bed to deal with a heavy soil and poor drainage, and then having half of that wash away, and then trying to continue on as if nothing had happened. It's better to go back to the beginning, start again, and start planting right, because a lesson we learned from Bernadine Strick over the years is that she would hammer home every chance she gets, is it's all about getting a good establishment right off the bat with a blueberry plant. And if that gets messed up, then it's hard to recover from that.
Well, it looks like we don't have any other questions for you, Eric.
Okay.
Oh, actually, hold on a moment.
Oh.
I do have another question for you. So, do you have any information on the impact of spilled pesticides, fertilizers, fuels, manures, etc., on the soil and water? So some of those water contamination issues that came with the flooding.
Yeah, I think I saw a news article yesterday that had a statement put out by the Ministry of Agriculture, because the Ministry of Agriculture had some testing done in the area, soil testing after the flooding. And I don't want to misquote it, but I think the bottom line was that there was no substantial concern about contamination in the flood zone. Somebody from the ministry that's more familiar with that might be able to correct me on what I'm saying. But the fuels that were potentially spilled, well, there was fuel spilled into the area. Those are hydrocarbons. A lot of them would have evaporated quite quickly. Anything that didn't evaporate, hydrocarbons are quite readily eaten by microorganisms. So once the waters had resided, I would suspect that microorganisms in the soil would just eat them and make most of it go away. Pesticides, I like to think of it maybe as a homeopathic effect. When you've got billions and billions of liters of water and a few jugs of pesticide that potentially got released, I would hope that dilution would have made that a non-issue. Yeah, there we go. Julie shared the article that was just published yesterday. Please check that out and don't take my word on it. And then the final part is manure. I mean, we apply manure. I think that there's a pre-harvest application interval of a few months in berry crops, and this happened a few months before that PHI would have come into play. And so we expected that any manure that would be that would have been spread around would have had no impact on the plant by this time of year when the crop starts to develop. And further, a lot of these fields are not being cropped, the blueberry fields in Sumas in particular. And so I don't have a lot of concerns about the potential contamination issues. I would have no problem eating blueberries from the farms just down the road from my house here in the Sumas Flats. Yeah.
Great. So there are a couple of other questions. But first I'll wrap up. There's also been a couple comments. Thank you. One of our attendees from the BC Ministry of Agriculture just wanted to comment that the Ministry of Environment tested the floodwater originally for pesticides, and that it wasn't a cause for concern at the time, and that most of what was detected were the fall-applied herbicides. So that hasn't been a major issue. So there is a question around which organization is responsible for the flood hydrologic modeling for the studies that you're working on?
I'm not sure what that means.
Was there, you weren't using any flood modeling or looking at future, you were just looking at the immediate flood impacts, correct?
That's right, yeah.
Okay.
I'm just a simple plant scientist. I don't know this hydrological modeling stuff.
Okay, so this question, I think this is one you probably could answer. It's just around the variety. So one of the things you mentioned was talking about what you would replant with. And you gave an example of replanting with Calypso. So does this have some better resistance to flood, or is this more, were there other reasons for you recommending that specific variety as a replant option?
Good question, Pragya, I can clarify my earlier comment. This is something I can answer. So Calypso, I meant that in terms of it being a variety that is currently being widely planted, because it presents a good market opportunity. It's a mid-late season variety. It's highly productive, and it's a nice firm fruit with good shelf life. So that was merely a suggestion that if a field of Elliott, which is a variety that's kind of on its way out in this industry based on its seasonality and its fruit quality characteristics, that the grower has a opportunity to replant with something that will be more profitable in the marketplace, and not particularly that it's more flood resistant, which is something I couldn't speak to.
Great. Well, thank you so much, Eric. I think that's all the questions we have for you for now, but I'm sure there will be a few people reaching out to you. And I guess one question I should ask, is there a place for people to access this information? I know that people often are interested in seeing these presentations afterwards, but do you have a link for where they can find the flood recommendations, management recommendations that you put together? And also where people can find, basically keep tabs on the ongoing research that you're doing on this. Where's the best place for them to go?
Yeah, we've disseminated the 2 documents that we put together in December and November by email and WhatsApp, but I'm gonna have to look into whether we have those posted on the internet. I think Lisa DeVetter may have them on the Washington State University website, but I'd have to check. But if you are interested in seeing those, please reach out to me and I'd be happy to share them. And at this point, maybe I need to come up with a plan for how to keep people up to date on things we're observing. Maybe we'll put it on the BC Blueberry Council website or something.
Okay, well, that sounds great. And also we can share those out in the follow-up materials after this webinar. And we'd be happy to post them too in the interim. So thank you so much. I think at this point, we'll take a 10-minute break and come back at about 10:05 and have our next session. So thank you, Eric.